on this one. Let's go with the square root of p squared minus 2p plus 1 minus 4 equals p. Square root of p squared minus 2p plus 1. Minus the 4 is not on the inside of the square root, not in the square root, and then equals p. So what's the first step we got here? Move the 4, yeah. Need the square root by itself, so I'm going to add 4, both sides. So I get the square root of p squared minus 2p plus 1 equals, now those, of course, those go out, but that doesn't combine, does it? Not like terms. Okay, so yeah, now we can square both sides. So I need to get rid of that square root, and squaring it will do that. The square root and the square will cancel out, so I get p squared minus 2p plus 1 equals, what happens here? Same thing that happened over here. Write it twice and FOIL. So p times p is p squared, p times 4 is 4p, 4 times p is 4p, and then 4 times 4, 16. With me on all that so far. Okay, so that's p squared minus 2p plus 1 equals p squared plus 8p plus 16. Like terms in the middle? I do believe so. Now what? Move them all over, okay? It doesn't matter. You can move whichever ones you want. There's 3 on each side, but yeah. If we move all these terms over there, subtract them. Subtract p squared both sides, subtract 8p both sides, and subtract 16 both sides. Notice what happens. Well, I've got p squared minus p squared. That's 0. Those go out. And then I have minus 10p minus 15, don't I? Those are gone, those are gone, those are gone. So this side is 0. And I wind up with this, which now what do I do? Well, the p squareds wind up going away, so now all I have to do is get p by itself. So let's move that 15 over to the other side and divide by negative 10. So add 15. Get negative 10p equals 15, divide by negative 10. And I've got p equals, that reduces by 5. Negative 3 halves, 1 1/2. I believe it would check out there. Question or concern? All right. Couple of other quick little problems here. Let's say I had a formula. And the formula was this: p equals the square root of ab over c. Okay? Yeah, it turns out you might, of course, encounter a square root in a formula, whatever it is there. And in this case, let's go with one of these, solve for a. Moving, basically moving everything besides the a over to the other side. But what I'm going to have to do is start this one. Well, since it's a square root, the a is under the square root. Wouldn't it be the same technique we're just talking about? Square both sides? Yeah, first step here is to square both sides. Because I need to get rid of that square root, and squaring it does that trick. Now this side is just p squared. The square root and the square will cancel out and just have an AB over C on the right. Now I'm trying to solve for A, so this gets back to other techniques we've talked about. How would I get the A by itself? Well, I can get rid of the c pretty easily by a couple ways you can look at it. I can multiply both sides by c. Wouldn't that cancel the c's out there? So p squared c equals ab, and since b is times the a, I would what? The b. Divide by the b. So I get p squared c over b equals a. That's what I'm solving for, right? Yep. Is that okay? All right. One other root equation here. What if it was, say, a cube root of 5x minus 1 equals 5? Back to just regular equation there, solving. But it's a cube root. Well, since it's a cube root, squaring won't do much good, but what do you think we would do? How about cube both sides? Yeah. Same thing works for any root. I mean, if it's a cube root, you cube both sides. If it's a fourth root, fourth power both sides. Yeah, just do the opposite thing. In a cube root, the opposite would be cubing both sides. And similarly, the cube root and the cube do cancel out. Yeah. So what we get? 5x minus 1 equals 125. 5 times 5 times 5. Add the 1, then 5x equals 126. Divide by 5, and x equals 126 over 5. Believe that? Question or concern?